Well, hopefully you've had a chance to look at some of the different functions and what they look like, because they are quite different. And this is the problem. If you think back to last year, all we did was graph reciprocal functions. It was always 1 over f of x. And there's very limited options to what could happen. We now have a lot of things to consider. These are difficult graphs to make, so we kind of have to look at each one individually. But there are some specific things you look for first. All right, so from yesterday's graphing, how could you determine the non-permissible values? Well, this is always from the denominator. All right, if the denominator, so you had something underneath here, all right, what you were looking for is where would this be 0? And if it was 0, something's going to happen there. Something. You're not sure what it is. There's either going to be a vertical asymptote, there could be what we call a hole, or sometimes it's referred to as a point of discontinuity. And then a third thing could happen. There could be a oblique asymptote. All right, but that's kind of a special case, and we'll get into that later. Okay, how can you tell whether the graph of a rational function has an asymptote or a hole at the non-permissible value? So the question is, which one of these is occurring? Well, it's pretty simple. All right, so let's say you have in the denominator, you have something like x minus a. If, when we factor, if the numerator also has x minus a, and these cancel, this will end up giving us a hole. All right, if there is no canceling, there will be a vertical asymptote. Okay, and then how can you tell whether a graph of a rational function has a horizontal asymptote? All right, there's actually 3 possibilities here. 3 things that could happen. Okay, and we'll get into this a little bit more specifically in the next lesson, but there could be a horizontal asymptote at y equals 0. This is what we had every single time last year. There could be an asymptote somewhere else. Okay, there could be another value, so it could move up or down. All right, or there could be no horizontal asymptote. And normally when there's no horizontal asymptote, there will be an oblique asymptote. Okay, so those are some of the things we're going to consider. Let's now get into really looking at these specifically. Okay, so there's a few things we need to consider. We'll look at them one at a time, and then at the end we'll try to put it all together. Okay, so here's your rational function. It's going to have something in the numerator, something in the denominator. It has to be an x in the numerator and denominator for it to be a rational function. Okay, and note here g of x can't be 0. So this is our first thing we're going to look at, the non-permissible values of x. In other words, where would the denominator be 0? Because something's going to happen there. Okay, so in this case, what are the non-permissible values? X cannot be 3 and negative 1. All right, because if we had those 2 values, you would have 0 in the denominator. All right, and now what happens at those locations? Well, because there's no factor that cancels out, we're going to have a vertical asymptote at x equals 3 and at x equals negative 1. Okay, so that's how you would start your graph. You would draw a vertical asymptote at x is negative 1 and x equals 3. A couple things about asymptotes. They are actually not part of the graph. If you go on Desmos, they will not have an asymptote. Asymptote is more about what's happening there. First of all, there will be no graph crossing the asymptote. Second of all, there has to be asymptotic behavior. So you're going to have the graph approaching this asymptote. Okay, so be careful that you're aware of that the dotted lines are actually not part of the graph. They're just there for us to know what to do. Okay, so that would be the first thing that you would do when you look at something like this. All right, and we're only looking at characteristic number 1. What would be the non-permissible values? Let's try the next one. Okay, this one's just slightly different. Here, again, if we look there, I know that x cannot be 3. That is a non-permissible value. But this time, x minus 3 would cancel out because that's a common factor. So we can reduce that. X minus 3 divided by x minus 3 is just 1. And so now you're left with the equation y equals x plus 1. But something still happens at x equals 3. Even though it's no longer in this equation, we still have to deal with it. What's happening at x equals 3? There will be a hole. The x value is 3. What is the y value? Well, the y value comes from what's left over in the equation. So you would go y equals 3 plus 1. This is 4. So there's a hole at 3, 4. Okay? And now let's graph this. How would you graph what's left over? Well, you know that the y-intercept is 1, and you know that the slope is 1. So we could draw this. Y-intercept is 1, and our slope is 1. So this is the point 1, 2. And if you went backwards, you would end up here at -1. So we can draw this line, but there is a hole right here at 3, 4. In other words, the graph doesn't exist there. It's a straight line with a hole in it. Okay? So that's actually one of the easier ones to graph because it just turns out to be a line. That one we can actually do without knowing any other information. All right, let's try this one. Now this one we're going to have to factor first. So you have x squared, and if I recognize difference of squares here, 2 minus x, 2 plus x, and looking, there is no factor that's going to disappear here. Nothing cancels out. So x cannot be plus or minus 2. What is happening at each of those? There is a vertical asymptote at 2. There is a vertical asymptote at -2. Okay, so we can draw that. X equals -2, and x equals +2. Okay, so that's looking at the first characteristic. That's the one I would always start with, figuring out what are the non-permissible values and what does it mean when you have that. Okay, one more. So if we factor this, this time we have something cancel out. But you still need to consider that x cannot be -5. Because it cancels out, there's going to be a hole at -5. All right, what's left in the equation? The equation is y equals x minus 5. So to get this value, I'm going to consider y equals, put x is -5 in there, and you get -10. Okay, and this allows us to graph. We have y-intercept of -5. We have the slope is 1. By the way, if you don't like graphing this way, okay, we could graph this way. We could say, let's figure out what the x-intercept is, and let's figure out what the y-intercept is. That's actually a great method as well. Okay, the x-intercept you would make y equals 0, and so x-intercept is 5, y-intercept is -5. Okay, so let's put that on the graph. You get -5, you get 5, and so we'll draw that line. And there is a hole at -5, -10. Okay, if you saw that on Desmos, the line wouldn't go through like that. We would have it go up to the hole and then start again like this. Okay, as long as you put a hole there, I know what you mean, that there's no value at that x-intercept. Sorry, at that x value. Okay? All right, I'll stop there, and then I'll make another video for the rest of this.